Today we're going to be talking about derivative of natural log of x. Alright, in order for us to do that, I want you to evaluate this limit expression. Limit of x, 1 plus 1 over x, to the x power as x approaches infinity. Alright, so I'm just going to give you a little bit of time first, and we'll continue. Alright, okay, now, so yeah, if you need more time, of course you can definitely work on it as you pause this video. Now, but in this case, one of the common answer in this case would have been this. Given that as x approaches infinity, this portion would have approached 0. That means, hey, many people's argument is that 1 to the whatever power would have been still be equal to 1. So therefore, one of the popular answers is 1. Now, but you will realize that that's not the case. In fact, if I were to use the calculator to show you, so let's first try to clear everything out, and we're going to have 1 plus 1 over x. Close the entire thing to the x power. Alright. Now, first if I simply graph this, as you can see, I'm going to have a graph that looks something like this. And as you can see, it's going up a little bit, maybe 1, 2, 3, I don't know, maybe it goes up to 4. We'll see about that, but in order for us to evaluate this a little bit further, what we will be doing is this. What if we have to input the values and then figure out what kind of value we'll be getting? So from the table set, what I will be doing is independent variable, which means x, I'm going to set that as ask. That means I get to input values for independent variable, and a dependent variable, which basically will be equal to y, will automatically be calculated. Given that, let's try to start. In the beginning, what if I were to put 10 for x value? Then on the y value, you will get something like this, 2.59. All right, then let's try to input maybe 100 this time. And you will realize that it's, somebody increasing, okay. Then maybe we'll go for 1,000. In fact, I ended up giving 10,000. Then it's increasing a little bit. Okay, let me just go for a little bit more. How about 1,000,000? And then see what happens. Oh, okay. So it became 2,718. 3. All right. Which will it be able to be 4? Let's try to go for a couple more numbers. Now this will be 100 million. Well, for the curiosity, let's try to see what happens here. Oh, I am almost getting the same value. Haha. This is quite interesting because what's happening is as x gets larger and larger number, just like in infinity, the y value doesn't seem to be actually growing. In fact, so what we have done was we set this value as e. E is 2.718, 2818, 2818, and continues. Not necessarily in the pattern, but other patterns of other patterns. In fact, therefore, e will be irrational number. Now, knowing this, what we'd like to do is this today. How do you define, or how do you find the derivative of the function ln of x against x? You see, to do this one, only one thing that which we can do is simply, or maybe I should make this one into number 3 now. Would have been limit as h approaches 0, ln of x plus h minus ln of x, and then divide holding by h. Now, once we have put this one in, we get to realize that, hey, we can use the properties of logarithm. You know, the subtraction implies the division, so we will end up having is limit as h approaches 0. We will have ln of x plus h over x. Entire thing divided by h. Now, then in this case, when you look into this one, when you simplify this one further, we'll be getting something like this. Dividing it by h simply becomes 1 over h of ln of 1 plus h over x. Now, that's basically what we end up getting. But once you look into this one, by the power rule of the logarithm, we can rewrite this one as limit as h approaches 0. We're going to have ln of 1 plus h over x to the 1 over h power. Now, but once you look into this portion, you will realize that this is very similar to the previous page, which is right over here. Now, but they're not exactly the same. As you can see, h over x, where x is a constant and h is the variable, that can be comparable to 1 over x. So one each thing which we can do in this case is let the side h over x is equal to, instead of saying 1 over x, we can call it another variable. How about 1 over a? Right? Now, then here there are a couple of things which we need to realize. What is 1 over h? In order for us to get 1 over h, to replace this expression, what we can do is this. Switching h and a, then we get a over x will be equal to 1 over h. Now we can take care of this one. This can be taken care of by original setup. And how about h? As h approaches 0, what will happen to this value, given that x is constant? A will get bigger, bigger, and bigger. In other words, this can be now rewritten as limit as a approaches infinity for the limit of ln of 1 plus, you see h of x, you're going to rewrite that one as 1 over a. Now, 1 over h now will be rewritten as a over x. Now, but by the power rule of the logarithm, x can actually come to the front, making the expression in this way. Limit as a approaches infinity, we will get 1 over x times ln of 1 plus 1 over a to the a power. Then by now, I'm sure you're recognizing that this portion, as a approaches infinity, this portion becomes e. So therefore, what we end up getting is limit as a approaches infinity. We have 1 over x times ln of e. Now we all know that ln of e is equal to 1. Therefore, our final answer is this. When you take the derivative against x, for the function ln of x, the result will be simply 1 over x. So alright, so knowing that from the previous page, what we like to do is we like to look at a couple of questions. So let's try to get from y equals maybe ln of uh, x squared. And then I want you to find dy over dx. How do you do this? Alright, so in this case, so what we can do is we can use the chain rule along with the derivative of the natural logarithm. So here what we would have done is this. First, we can bring down 1 over x squared. But we also have to multiply by derivative of the inside, which is 2x. Then x's will cancel out. We'll end up having 2 over x. Alright, now, oh wait a minute, but some of you guys might be thinking in another way. Yes, in fact, there are more than one way for us to approach these kind of questions, especially using the properties of logarithm. Here, by the power rule, this in fact can be equal to 2 ln of x. Then in this case, dy over dx simply becomes 2 times 1 over x, which is equal to 2 over x, same as the other one. Okay. Now then, it's quite interesting because we could do this one in a couple of different ways. What if I were to give you next question? Knowing if y equals ln of x, and then y equals ln of 2x, and maybe y equals ln of 3x. Now, first we know that y prime here is equal to 1 over x. That's quite clear. That's how we defined it to be. Derived it. But how about the second case? Here we have y is equal to 1 over 2x times derivative of the inside, which is 2. Oh, but 2 cancels out. Interesting. So here we have y prime is equal to 1 over x. How about the third one? Y prime. Oh, wait a minute. They look rather similar, so why don't I try to do the third one a little bit differently? You see, when we have multiplication in the logarithm, what we can do is that's equal to ln of 3 plus ln of x. But notice that ln of 3, that's a constant. So when you take the derivative, it simply becomes 0 plus 1 over x, which ultimately becomes 1 over x too. Wait a minute, we started with the 3 different questions, but we all ended up in one place. How could it be possible? In fact, generally speaking, when you have y equals ln of kx, where k is a real number, some sort of constant coefficient, then this can be rewritten as ln of k plus ln of x. But as you take the derivative, ln of k simply becomes 0 plus 1 over x. So one way or the other, we will end up getting 1 over x if we have coefficient onto the x in the logarithm. Alright, great. So then, let me try to get you a couple more questions, and then we'll try to practice and see how it goes. What if I were to say let y equals ln of sine of x, where sine of x, in this case, has to be positive. Then how can we find dy over dx? In fact, this is not as difficult as it looks. First, we have to take the derivative of ln, which is simply 1 over sine of x. Now we have to take the derivative of inside, which is simply sine of x. Then we get cosine of x as a derivative of sine of x. And when you combine them together, we will have cosine of x over sine of x, which simply now becomes cotangent of x. Alright, Thank you, and then I'll see you later, and we will have more practice questions at the end of the chapter. Have a nice day.